The DR does reduce flooding, but that's only partially the truth. Let me explain. In my mind, OSPF is a cartographer responsible for making maps. These maps describe topology or structure of the network to the SPF process or algorithm. Dijkstra, or shortest path first, like a navigator, uses the topology map to make decisions on the best path to take. The key to understand the truth lies in understanding how SPF understands topology, aka structure. SPF understands topology objects and the relationship between them called edges. In the context of SPF, a router is a topology object called a node, a router node. It would be represented by the blue circle. A link is the edge and represents the connection or relationship between the routers. Router node 1 and router node 2 are related through this link, aka an edge. Topology is at least two nodes connected by an edge. Let's view how one router and its network is described. On the provided lab, log into router 1. The interface gig00 has already been configured for OSPF process 1, area 0. Issue the command show IP-OSPF database to reveal the LSA type 1, followed by the command to reveal the contents of that LSA. This output describes one node, and the contents reveal the details about that node. The node is connected to a stub network. In the context of describing topology, a stub simply means that router 1 has direct reachability to that network. This description correctly describes the physical network. This still is not topology. Recall, topology is at least two nodes connected by an edge. Topology is, at the least, a full point-to-point connection. Return to the lab. On router 1, change the OSPF network type to point-to-point. Then log into router 2 and configure interface gig00 for the OSPF process 1, area 0, and also change the network type to point-to-point. The link state database now describes two nodes. Take a quick look at the contents of each router's router LSA. The contents are clearly different, and that is because there is now topology. Previously, router 1 had this one entry that described the connected network for the purpose of relaying reachability. The meaning remains the same, as the 123.1.0/24 network is still reachable on that link. The new entry adds additional description about the link. The link is point-to-point, meaning only one other node is connected. The router ID of that other node is here, router 2. Router 1 is connected to the network 123.1.1.0/24 and also connected to router 2. Router 2's type 1 contents are similar to that of router 1. Router 2 has a point-to-point connection to router 1. The SPF and physical view are still identical. With all that out the way, let me get to the part about partial truths. Here's a shared network. We know that shared networks are multi-access. In some multi-access networks, devices have reachability and can exchange broadcast. In others, devices have reachability but are unable to exchange broadcast. The links between these devices are removed. The shared network will be described using SPF's topology rules. Each node is connected to the others. Easy, right? The SPF view is converted to physical view. That is not the network we started with. On the left is the initial network, and on the right is what SPF believes is the topology, a network with 3 point-to-point links. Return to the lab and on routers 2 and 1, change the OSPF network type back to broadcast. This is done by issuing the command no IP OSPF network. Broadcast is the default type on multi-access networks. Issue the command to view the link state database. There is now a type 2. Take a look at router 1's router LSA. Once again, the contents have changed. There is one entry. Now take a look at the type 2. Quickly log into router 3 and issue the commands to make it also appear within the type 2. SPF understands nodes and edges, but that only allows proper description of point-to-point links. For this reason, another node type had to be defined. This node is called a network node. The network node represents the shared network. The IP of the designated router and the mask reveal the network 123.1.1.0/24. Here are the router IDs of the nodes connected to the pseudonode. Router 1 connects to a transit network, which is code for multi-access pseudonode. This follows the SPF topology rules because the one pseudonode has a connection to each of the router nodes. The router nodes no longer have to connect to each other, meaning the true topology can be accurately described. After all, topology is the connection between one topology object, router or network, and another. Conversion from SPF view to physical view is the same. The shared network is now accurately described. We add a fourth node, and you see how easily that can be described by adding it to the pseudonode. The whole truth is that the DR does reduce flooding, but this is a side effect created because OSPF introduced the network node so that SPF could comprehend the topology of shared networks. A new node type created a new role, which was the DR. The DR generates the type 2 for the pseudonode and keeps track of all the routers connected to it. Now that is the truth, the whole truth, and nothing but the truth.